Okay, so I will share the screen. Okay, can see the screen? Can see the vertical line test?
Cannot, teacher.
Cannot ah?
It's
Cannot.
black.
Lag again ah? Why ah? I'm presenting what? I'm sharing what? But someone say yes. Chuang Pei Chi say yes.
Teacher, now can.
Huh? Sorry?
Now can.
Okay, so I go back to the screen. Okay, ah? Okay, so now I go through again this. Okay, this test, we call it vertical line test. Okay, vertical is we want to see whether the relation given is a function or not. Okay, so I just want to mention here, okay, if the vertical line that you draw does not cut the graph at any point, okay, or cut then more than one point, then this is not a function. Okay, so if only cut one point, then this is functions. So you got to assume this is a extended infinity. Okay. So you draw a vertical line. Okay, any place. We come to this. Okay, now you draw the vertical line. Okay, on the graph here, do a vertical line test to test whether the graph is a function or not. Okay, so look at A. When we do the test, we don't do it purposely on the x equals to 1. We don't do it purposely here. It's because this functions, okay, is not defined, okay, at x equals to 1. Can you see? Except when x equals to 1. We don't purposely go and do the vertical line test here. Okay, after I will tell you why. Okay, so for others, when you draw vertical line, when you draw vertical line, okay, you will see you will only cut 1 point, Therefore, this is function. Okay, for A. Then for the B, same thing. Okay, when you draw vertical line, it's only cut 1 point. So B also is a function. Okay, but for C, when you draw vertical line, my vertical line becomes slanting already. Okay, again, when you draw vertical line, okay, E will cut 2 points. Therefore, C is not a function. Okay, C, this is not a function. Okay, next, this one is the one you cannot hear me. Okay, this is the questions A just now, the example 2 questions A just now. Okay, so this one, the syllabus want us to mention to you. Okay, when you have this kind of functions, we call it fraction function. Okay, we call it fraction function. Where do I write? Okay, I write here, fractions function. Okay, means the function itself, you can see this is a fractions. Okay, so you have to define this. You have to define this because the denominator cannot be 0. Now, I write here, the denominator, which is x minus 1, cannot be 0. Therefore, x cannot be 1. Okay? If you have this kind of function immediately, okay, telling that, okay, yes, this function, you can have these functions for all the x except x is 1. X is 1, this function is not defined. Okay, now, okay, we want to learn a few symbol or the terms here. Okay, you look at this. X and then the arrow, 1 negative. Okay, this one it means x approaches 1 from the left. Okay, then what will happen to the fx? Okay, that day you remember I asked you to substitute. Okay, you choose a number that very near to 1 but it's not 1. Okay, from the left. Okay, mean it's smaller than 1. No? From the left mean it's smaller than 1. Okay, but have to be very near to 1. So first you choose 0.99. Then you substitute inside the functions, you get negative 99. I remember afterwards I asked you to choose 0.999, even nearer to 1. Now it's, I try to put nearer and nearer to 1. So I substitute inside the functions. So 0.999 over 0.999 minus 1. I remember you tell me this. Okay, so actually you can continue. Okay, just now 999. Now I got 49. You can see now it's very, very, very close to 1 already. Okay, actually you don't have to use calculator. You already know this answer will be 1, 2, 3, 4. Okay, 49. Okay, you see the number from negative 99, negative 999, negative 9999. The number is become very, very big, but from the negative side. Therefore, you see, it become very, very big from the negative side. Very, very big. It go down some more, it go down some more, it go down some more. But it will not touch 1. Okay, then from the right hand side the same thing. Okay, so x, the arrow 1 plus, it means x approaches 1 from the right, means after 1 or bigger than 1, that a number very close to 1. Okay, let's say we start with, I don't know where to write already. Okay, I start with 0, sorry, not 0. Okay, it must be bigger than 1. So, let's say I start with bigger than 1, 1.1. Okay, so I give you some time. You substitute inside the functions and tell me what's the answer if 1.1. You can type at the chat. Okay, someone tell me 11. Emmeline and Hasina. Okay, they tell me it's 11. Very good. Okay, the answer is 11. Okay, now, okay, 1.1, I feel that it's not close enough to 1. I want something nearer to 1. Okay, maybe I choose 1.01. Is it nearer to 1? compared to 1.1. Okay, this one is 0.1 away from 1. This one is 0.01 away from 1. Okay, this one is nearer than this. Okay, come on. Now you calculate and let me know what's the answer. 1.01. Someone told me already once. Okay. Okay, I want one more. 1.001. How about this? Thousand and one. Okay, very good. 1001. 1001. Okay, so if you see the patterns here, you know that if I put 1.0001, this one will be 10001. The number is become bigger and bigger when the x is nearer to 1. Can you see the graph here? When the graph is nearer to 1 but cannot touch 1, okay, the number is become bigger and bigger, means bigger and bigger, going up, shoot up here, bigger and bigger. Okay, don't know go until when. Okay, same as that just now. It become bigger and bigger, but it's at the negative side. It will continue, but no end. Okay, it just cannot touch this line. Okay, actually that is a name of this line. Okay, I want to use another color. Sorry. Okay, actually there is a name of this line, this dotted one. You shouldn't touch this line, your graph when you draw. Okay, okay, I label here. Okay, the name of this line, we call it asymptote. Okay, asymptote. So you can go internet and check what is the meaning of this asymptote. So I just introduce to you this term only, but I'm not going to mention more. Okay, when you I think go to Form 5, if not mistaken, you will see this word again, asymptote. Okay. So that's all for the question example 2A. Okay, so we just want to mention to you, when you write this function, this kind of functions, you write fx, okay, when this is fraction function, x minus 1, you remember after the function, put a comma, you got to write and tell, okay, the x cannot be 1. This is complete. This is how you write a function plus this. Okay, you have to tell where this function is not defined. Okay, therefore, when you do the vertical line test, you can't purposely go and test on this point, because you know already at this point, this function is not defined. Okay, therefore, okay, this graph is still a function because we don't test on this. If you test on this, they didn't cut through any point, then you will say, oh, this is not function. Not correct. This graph is function. Okay, because you shouldn't test on the asymptote. You got to test at other point. Okay, when you test at other point, it's only cut through one point. Therefore, this is a function. Okay, so I think I'm clear. Okay, second one, other than 2A, they want us to mention to you, okay, 2B as well. Okay, let us look at 2B. 2B, this type of function is also a spatial function. Okay, you see the two lines. Okay, you see these two lines. This one we read as modulus. Okay, so fx is equal to modulus of x. Okay, this one we read it. Fx is equal to modulus of x. Okay, what is the definition of the modulus of x? This is very important, no? Okay, this one must copy in your notes. Put a tick here. Okay, so modulus of x means if whatever things inside the modulus is positive, then you remain it. If whatever inside here is negative, you got to change the negative into positive. How you want to change the negative into positive? You make a negative in front. Okay, so negative, it will become positive. Okay, let us see this example. Okay, if x is -2, with the modulus, it will change to positive. Okay, if the x is positive 2, okay, then it will remain as 2. Okay, this is a meaning. Okay, so you just have to know, okay, this is functions of absolute value. But when we read, it's a modulus of x. Okay, anything not clear before I continue? Okay, one more thing is the shape of this type of a graph is a V shape. And then afterwards, I will teach you how to sketch this type of graph, but it's not now, afterwards. Nobody say anything, so I guess got no problems. Okay, I come back here. Okay, then I continue. Okay, example 3. Today actually I talk to myself only. Okay, I have go through the example 3, but I guess nobody can hear me. Okay, so look at this example. Based on the diagram on the right, write the relation of a function g by using function notation. So you see I highlight here function notation. You must use function notation if they say by using function notation. Okay, so the function notation of the function is, okay, look at this. How do I know it's x squared? Okay, we see one by one. Okay, -3 as object, map to 9 is an image. Okay, object image. Okay, so -3, what you do to the -3 so that it will become 9. Okay, maybe you can see not very clear. Okay, then you see the second example. What you do, okay, as the same process like just now, what you did to the -3. Okay, you'll make the 2 become 4. Same as this. Okay, same process like just now for the 2 example. Okay, you do the same thing to 3, you will make it become 9. And then last one, okay, 5. What you have to do to the 5, okay, same process like just now, that 3 example, you will make it become 25. Obviously, you just square it. Okay, means what? -3, you square it, you get 9. 2, you square it, you get 4. 3, you square it, you get 9. 5, you square it, you get 25. You must make sure for every example, I mean every, how to say, the object here, okay, follow the correct functions that you're going to use or you're going to write. Okay, so if confirm x squared, then you write, okay, gx is x squared. You can either write this, if not, you can either write this way. Okay, g double dot x, okay, and then arrow x squared. But this one, you got to find by yourself. This one, you got to find by yourself. Sometimes the function is quite simple, but sometimes it's not. Okay? Okay, I think this is the day one. Okay, I have used up one period. Okay, I want to continue. Okay, this part actually for today. Okay, first of all, I want you to know this. What is the meaning of discrete functions and what's the meaning of these continuous functions? Okay, graph of continuous function, graph of discrete functions. Okay, if you see, okay, point on the graph of the discrete function are real. Okay, wait for a while, bearing. Okay, come back. Okay, sorry, I repeat. Graph of discrete function are real, separated and not connected by straight line or a curve. Okay, this is discrete function. Okay, maybe by words explanation is not clear, but when you see, okay, when you see the graph, okay, it's clear. You see, it's only a dot, a dot, a dot, and a dot. Okay, but it's not joined by a curve or a straight line. This one we call it discrete function. Okay, if example, if here is 1, here, okay, maybe 2, they don't have data, maybe here is 3, 4, and then 5. If the question asks you, okay, F2, what's your answer for the discrete functions? Anyone want to try? Uh-oh. Still with me? I'm not sure whether the line is okay.
Yeah, teacher, we are here.
Okay. So anyone want to try? Just now, discrete function, F2. If I label here, okay, this x value, this is 1, this is 3, this is 4, this is 5. There is no 2 here. So what is F2? Okay, you can type in the chat room. Nobody want to answer? The answer is no answer. The answer is no answer. Okay, right? The answer is no answer. Okay, because there's no value here. Okay, another example. How about this? 4.5. I wait for a while. What's the answer? Hello, what's the answer? No answer, yes. Cheru, correct. Okay, no answer for F 4.5 as well. Okay, no answer. Okay, but for this different. Okay, for continuous function is different. Okay, let us see. As for the graph of continuous functions, the points are connected by straight line or the curve within the given interval. Okay, so let's say, okay, let's say here is 1. Okay, here is 5. Okay, if the question asks for F2, okay, example 2, 3, 4, this is 2. So you got to read from here. Okay, this is 2. You got to read from here. Then that one got answer. Okay, if the example asks for F4.5, same thing. Here is 4, here is 5. Okay, 4.5 is in the between. Okay, so go up. Okay, then bend and go at the side. Okay, that is answer for F4.5 and F2. This is the meaning, this is the difference in between discrete and the continuous function. I hope this is clear. Okay, next, we want to see, okay, what is the meaning of the domain and what is the meaning of the range. After that, we want to see what is the meaning of the codomain. Okay, Look at this part. Look at these notes given. Okay, domain. Okay, domain actually is the x value. Okay, the best. Okay, and then the range. Okay, range is the value of the y. Okay, that are obtained by substituting all the positive x. Okay, this one is after we want to see what is the difference in between the range and the codomain. Okay, and this is how we differentiate afterwards. Okay, the range and codomain. Okay, so now domain is the value of the x, range is the value of the y. Okay, let us see both discrete and the continuous function. So the domain for the discrete function will be here, this value. Okay, then the range will be this value. See, so this one they will write in set function, set notation. Sorry. Okay, then this one also they will write in a set notation, and then it's a discrete, means one number, one number, one number, one number. Okay, but for continuous functions, you see, this domain is a continuous. Okay, usually they will write in an inequality. Okay, for domain. Inequality. Domain is the x value. Okay, it's either got equal or not equal. Sometimes got equal, sometimes got no equal. Okay, and then range. Range is the y value, which is the fx. Okay, they write in an inequality. Okay, so this is a difference in between the discrete function and the continuous function. Okay, the way they write the domain and the range. Okay, now we want to see what is the difference in between the range and codomain. Okay, so it's very simple. We just look at this example. Okay, domain is the x value. So for this case, this is a discrete functions. Okay, so the domain is this 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay, domain. Okay. Range will be the x value that, I repeat, okay, the x value that are obtained by substituting all the possible value of the x. I go up a bit. Now, the one I highlight, the one I put bracket. Okay, the range is what? The value of y that are obtained by substituting all the possible value of the x. Okay, means you substitute 1, you get 3. You substitute 2, you get 5. You substitute 3, you get 7. You substitute 4, you get 9. But the 11, you don't see, because nothing you will get 11. So the range will be 3, 5, 7, and 9. Okay, the range will be 3, 5, 7, and 9. This is from the definitions, how you get the difference in between range and codomain. Okay, so the codomain will be everything, whatever you see, I don't care, they got object or they got no object, okay, inside this. This one we call it codomain. Okay, so I hope I made it clear. Okay, we go to next page. Okay, let us see one by one. Okay, look at A, domain. Okay, is the value or whatever lah, from the x. So you have a PQRS here. Okay, range is the one got object, so it's 1, 3, 7, 9. Codomain is don't care, whatever inside the set y, so it's 1, 3, 4, 7, 9. Okay, look at B. Okay, discrete functions. So we start with domain. Okay, domain is here, is a value here. Okay, so this is -2, this is 0, this is 2, this is 4. Okay, this one is in between 0 to 2, this is 1. And this is in between 2 to 4, this is 3. Therefore, domain. Okay, -2, 0, 1, 2, 3, 4. Or you are reading from the x value. Okay, and then for the codomain and the range, because this type is not same as this, so I don't know what is the extra here. What is the extra here? So the codomain and the range will be the same. Okay, how do I read? Okay, so when -2, you match. Okay, so this is 1. Okay, so the range, the first one is 1. Okay, then we look at the second point. When x is 0, okay, the effect is 3. Therefore, I have 3. Okay, then this point, okay, I guess this is 4. 4, after 4, I think this is 5. Therefore, you have 5 here. Okay, then how about this point? This point, the fx is 2. So you have 2 here. Okay, these 2 points, the fx is same value. So you have a 4. Okay, then you have 4 here. Therefore, the range is 1, 2, 3, 4, 5. The codomain are the same. Okay, look at C. Okay, C, the same thing. The range and the codomain are the same. Okay, only this type of questions, the range and the codomain, okay, will be slightly different. Okay, because you see, there is a number in the set Y, but it's not matched with the object. But these two types, I don't think you can see the difference in between the codomain and the range. Okay, so for continuous functions, the domain is at the x. So it's from here to here. Okay, as I say, they will write in the inequality form. Okay, so remember for domain, this is x. For range and the codomain, this is fx. Okay, if you write wrongly, the whole thing gone. Okay, so for domain, okay, it's from from 0 to 3. Okay, including 0 and 3. Therefore, you have an equal sign. You have an equal sign. Okay, then range will be from here to here. Range will be from here, the lowest, okay, of the fx until the highest of the fx. So here will be the range, or the codomain the same. Okay, so if from 2 to 6, from 2 to 6, okay, including 2 and 6, including 2 and 6, okay, fx. Okay, next. Are you still with me?
Yes, yes.
Okay, don't fall to sleep. Okay, next is the sketching of the modulus graph. Just now we mentioned, right, the modulus, the definition of the modulus. Okay, now I have to teach you how to sketch this type of the graph. Okay, I don't want you to follow this. I don't want you to follow this. This one don't want. Okay, I have a simple method for this. Okay, so let's say, where do I go? I go to, I'm not sure, maybe I go to paint. What can I draw? Okay, the function is 2x minus 1. Okay, this is a function. Now you got to sketch. Okay, sketch these functions. Okay, they give you domain. In the questions, they give you domain. Okay, after that, after you sketch, you got to state the corresponding range, okay, of f of the given domain. Okay, so two parts of the questions. First, you got to sketch. Second, after that, you got to mention what is the range, what is the corresponding range of this domain. Okay, so first part, how do you sketch? Okay, so you see the domain, starting point and ending point. So you just substitute inside the functions, the starting point and the ending point. Okay, I wait for you a while. Give me the answer. Okay, oh, Ravina asked, but if in the discrete function f4 got answer, 4 just now, yeah, yeah. Someone say -3, not -3, not -3, not -3, okay, I come back here, not negative. Because after the modulus, you remember after the modulus, it will change anything negative in positive. So it will become 3. If follow the definitions, if this is negative, you've got to put negative of -3. Then it will come to 3. In another way, you can think of this way. Okay, whatever things inside the modulus, if negative, you got to change into positive. Therefore, the answer is 3. It's not 3. Okay, the second one, I saw some give me answer is 3. So I substitute here, -1. So this is 4 minus 1 is 3. So inside the modulus is 3, then it remains the same thing, which is 3. Okay, so I have these 2 points done. Okay, one more point that you need to get for modulus function will be, let the fx be 0. Okay, then get the value of the x. Okay, so modulus fx is what? Modulus 2x minus 1. Okay, so replace the fx with modulus 2x minus 1, let it become 0. Okay, because this is 0, therefore you can ignore the modulus. Okay, there is no positive 0, there is no negative 0. Okay, 0 is just 0, so you can just ignore the modulus. Therefore, this is 2x minus 1 equals to 0. Okay, other days I will teach you if this is not 0, then how. But today I will just mention to you, if this is 0, you can just take away the modulus, ignore the modulus, because there is no positive or negative 0. Okay, then you solve for the x. So 2x is equal to 1, then x is equal to half. Okay, so 1, 2, 3. 3 points I have. So I want to I want to sketch the graph by using these 3 points. Okay, so you must use ruler. I got no ruler. Okay, so 1 point is a -1. And then the skew, please, uniform. So this is 0, this is 1, this is 2. So I have -1 to 2. Okay, then both answer are 3. So 1, 2, 3. 3 is here. So the first point is here, -1, 3. Second point is 2, 3. Then third point, blah, 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 blah. Third point will be this. Okay, when fx is 0, x is half. So x is half. So I need, sorry, this is x, this is fx. X is half, so I need here is half. Fx is 0, so here. Okay, remember the shape of the graph of modulus is a V shape. Use ruler, join this to this. Ayo, sorry, and join this to this. A V shape. Okay, done. Okay, so remember, don't follow your textbook, use that table. Okay, you just find the beginning of point, okay, follow the domain, and then the end point, and then let the fx equal to 0. These three things, okay, these 3 points will get you the V shape. Okay, now answer the questions. Okay, you got to state the corresponding range of f for the given domain. Okay, maybe I go back to textbook, let you see the questions. Textbook, where are you? Textbook, is it this? Okay. Again, the question is, function f is defined as this. Sketch. So the first thing you've got to sketch the graph of f in domain, in this domain. Okay. Second thing, you've got to state the corresponding range of the given domain. Means follow this domain, what is the range? What is the range? Okay, so I come back here. You see, range, when you want to answer for range, okay, you got to see this part. Okay, this is the highest point or the tallest point, and this is the lowest point. Here is 0, 0 to 3. Okay, 0 to 3. Okay, remember, sorry, this is equal sign. This is equal sign because your domain got equal sign. Your domain got equal sign, so your range also got the equal sign. Okay, remember range is fx, domain is x. Okay, then you write this is range, double dot. Okay, so I have answered for this part. I still have 8 more minutes. Okay, there is another way of sketching this type of graph. So I would like to mention to you. Or maybe I open a new one. But this one I want to send to you, I better save. You wait for me a while, sorry. Go to your. Okay, okay, I open a new one. Okay. Another methods, how to draw this, how to sketch this. 2x minus 1. Okay, so you just at first sketch 2x minus 1, the one without the modulus first. Okay, the same domain, -1 to 2. Okay, means if I want to sketch this, the one without modulus, I do the same thing like just now. I find the 2 endpoint. Okay, but now it's without the modulus. So 2, -1 minus 1. So this one will give you -3, and then 2 times 2 minus 1. This one will give you 3. Okay, now I quickly sketch it. Okay, so this is -1. This is 1, 2. This is 0. This is x. Girl, you don't draw for me freehand. Afterwards, you must use ruler and then use a uniform scale. 1, 2, 3. And then, sorry, this one got negative, so come down. 1, 2, 3. So -3 here. This is 3. So -1 is -3, 1 point here. 2 is 3, 1 point here. Okay, so straight line. Okay, use ruler draw. Okay, so this is the one without modulus. So with modulus, it's very simple. Okay, now I've changed to another color. This color. Okay. See? Okay, so you just see where the graph, where the straight line cut the x-axis at this point, right? Okay, so you just bend, reflect like a mirror. So this part refract go up. Okay, so the negative 3 will come to 3. Okay, then this part remain. So you see, your dot 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 one is the modulus. Okay, the black color one is the without modulus. I better join it solid lah, solid. Because solid always represent the correct answer. I mean the final answer. Solid, sorry. Okay, so the orange color one is the one with modulus. The black color one is the one without modulus. So for the modulus graph, you can sketch by using this way as well. Okay, but this one you've got to follow exactly the scale, because they want to know this point also. They want to know what is this also. Okay, if you follow the scale, you will know this is exactly at 1/2. If not, you got to find it, like just now. You find fx equal to 0. 2x minus 1 equal to 0. Okay, to confirm, okay, this is exactly at 1/2. I don't want you to just see from the graph and then make conclusions, but sometimes it's run a little bit, then gone. Okay, so 2x is 1, so confirm x is half, therefore this is half. Then you got to label this is half. Okay. I have 3 more minutes. I don't think I can continue. Okay, so I will go through with you, okay, whatever what you need to do for today. Okay, so first of all, for those that day you didn't do notes for the vertical line test, okay, you continue with the vertical line test the notes, and then followed by, okay, maybe I open back the textbook. This is the textbook. Okay, continue in the same book. Okay, so for those didn't do yet the vertical line test, so you do vertical line test, the notes. Okay, after that, these two functions, okay, you must write down. So one is the fraction functions, okay, the notes for fraction functions, the notes for the absolute value functions, okay. After that, this one is your homework. Okay, homework and the notes in the same book. Okay, continue until here. Altogether 3 questions as a homework. Remember, after you do it, you can check the answer. Okay. Then after that, this one nothing. After this will be this. Okay, discrete and the continuous functions. Hey, before that, the day I mentioned about the index. Someone on the mic? Uh-oh. Huh? Yes? Yes or no?
Citizen.
Huh? Sorry?
No, teacher.
No. Okay, so that day, the index, please write the date of that day, and then please write the title for the index is function. Okay, and then today, the index, please write this. Domain and range. Okay, I write here, this is the index for today. Okay, then you continue. Okay, so this one you have to write what is the meaning of domain, range, and then what is discrete function, what is continuous functions. This one you write in your notes, and then what is codomain by using this example. Okay, after that, okay, sketching of a modulus graph. Okay, just now I give you the 2 methods. If you know already which method you want to use, you can just show one method. If you like both methods, you can show both methods. Okay, then after that, this one as your homework as well. Okay, so you can see question number 2, you got to sketch 3 modulus graph and then state the range. Okay, I think that's all for today. So you got to do skill practice 1.1, 1.2 as your homework, and then the notes as well. Okay, wait don't go yet. Okay, so I will stop recording. Okay, any question to ask?